Welcome to Future Explorations. I'm glad you can join us. My name is Victor Martinez, and this podcast is dedicated to the exploration of the diversity in perspectives around the concepts of change as a constant we humans need to embrace, long-term thinking as an approach for everything we should build and create, and the limits that our human nature, physiology, society, environment, and technology impose on us by their own intrinsic characteristics. It is your task and mine to identify the connections between all views, to discover the interdependence and complementarity of knowledge and ideas. In that way, we might get a clearer picture of what that sustainable future could look like and how we can design the transition to get us there. This time I have the great honor to talk to Dr. Carlos Gershenson. Dr. Carlos Gershenson is a tenured research professor at the National University in Mexico, UNAM. He studied a master in evolutionary and adaptive systems from the School of Cognitive and Computer Sciences of the University of Sussex, and a PhD on design and control of self-organizing systems at the Center Leo Apostel for Interdisciplinary Studies of the Dutch-speaking Free University of Brussels, and a postdoc at the New England Complex Systems Institute. He has a broad variety of academic interests, including self-organizing systems, complexity, artificial life, information, evolution, cognition, artificial societies, and philosophy. He is leader of the Self-Organizing Systems Lab, and he was head of the Computer Science Department of the Applied Mathematics and Systems Research Institute at UNAM. He is also an associated researcher with the Complexity Science Center at UNAM. He spent a sabbatical year as a visiting professor at Sensible City Lab at MIT and at MOBS Lab in Northeastern University. Dr. Gershenson, thank you very much for accepting the invitation. Thank you very much for being here.
It's a pleasure. Thank you for the invitation.
Excellent. If you could please just tell us a little bit about yourself, an informal way of introducing you, and what led you to study complexity.
Yes, so I'm a research professor at the National University in Mexico. And I became interested already as an undergrad in studying complex systems more than 20 years ago. So since then, I've been studying different aspects of complex systems, in particular self-organization, information, and many other things. And let's say my original formation is in computer engineering and philosophy, but from there I have interests in applying complexity to solve real-world problems, but also using theory to propose measures of complexity and self-organization and emergence, and also addressing philosophical issues that have to do with epistemology of complex systems.
Excellent. That sounds super interesting. What was your first exposure to complexity theory? How did you discover it? Was through computation?
Yes, I think we were in first semesters of our bachelor's, and one of our teachers showed us Conway's Game of Life in a computer simulation, and that just blew my mind.
Yeah.
And from there, I started learning about all sorts of complex system models, and then I began to build my own models of complex systems, and it's been a non-stop roller coaster since then.
And the research that you do nowadays is focusing on what?
Well, we have different projects with different collaborators and students. With several of them, we're studying rank dynamics, how different elements change their rank in time, from words to teams or players in sports, to countries, to economies, to companies, and so on. So that's something interesting. We also have several applications to urban mobility, trying to improve different systems, for example, traffic light coordination, public transportation, regulation, crowd control, more more recently with a PhD student, we're studying the effect of adaptable reversible lanes in cities, and also an epistemology of information I've been working on. Also the effect of heterogeneity in complex systems, which is something which, let's say, many people are starting to work on, but it seems it's much more relevant than we previously thought. So there's some interesting results we have in that direction.
No, okay. I never thought about or heard about the.
Yeah.
Yes, it's interesting. Okay, so the conversations that I've been having with different experts in different fields is normally aligned to three main concepts. These are change, a broad idea of what change means in complex systems and how it works, and long-term thinking, and the other one is limits. So I have a few questions, but obviously depending on the conversation, we can just go wherever you want. So as a general starter, in terms of change, in complex system, how change happens or does not happen? What is it that prompts change in complex systems? Or maybe we can just give a step behind before and explain what makes a system complex.
Yeah, let's start with what makes a system complex and then change in general, and then we'll
of course
merge both.
Yes.
So, well, there are dozens of definitions of complexity, but if we go to the etymology, it comes from the Latin plexus, which means intertwined. So something complex is something that is difficult to separate. Why something might be difficult to separate in its more simpler components? Because it has relevant interactions. So those relevant interactions, they have several implications. One, of course, that you cannot study the components in isolation, because you need to consider what's the state, what's the effect of one component in another, in order to predict or understand or study not only the components, but also the system. Mm-hmm. But perhaps the most relevant implication is that these interactions generate novel information that it's not present in initial nor-boundary conditions. So this limits prediction, and this implies a change of worldview that, as opposed to traditional reductionist worldview that was pushed forward by successful reductionist approaches to science, that, I mean, they're successful, but they're limited.
Of course.
In the sense that if you cannot predict what will be the future of a system, then let's say our unspoken assumption that the universe is predictable and we just need to find the right laws in order to predict it and control it for our own benefit, it's completely mistaken.
Yeah.
So instead of trying to do that, an epistemology based on, well, acknowledging the reality of interactions and its limits on prediction, basically shifts our control over nature to better understanding nature and taking our place inside it.
Yeah. So the idea will be to understand the relations between different, let's say, entities or actors, if you want, in a certain environment, and how these actors exchange or interact and interdepend between them. That interdependence is what creates the complexity in the system. Those exchanges, those interactions, and the idea of reductionism came, and it's being still today, obviously, in many branches of science. It's successful. It's a successful model. Why? Is the why not dealing complexity within all the different branches of science? What has been holding us back, or why we didn't start it that way?
Yes, well, we didn't have the appropriate tools to study complexity. So let's say the reductionist approach comes from times of Galileo, Newton, Laplace, and Descartes. And let's say its basic principle is, let's try to isolate phenomena in order to predict and control them. And it has been successful because there are many phenomena which you can study in isolation and control and predict, and that has allowed huge progress, not only in physics and chemistry and engineering, but also in medicine and well, in many aspects of our culture. However, that doesn't mean that it doesn't have limits, but we didn't have, I mean, even if you have a huge blackboard, or you're limited to the number of variables that you can consider with pen and paper.
Yes, of course.
So it's not a coincidence that it was only with the development of computers that complex systems were able to be studied systematically. I mean, there are like few examples before computers, and actually by the founders of computer science, for example, Alan Turing, Sean von Neumann, who proposed cellular automata, and others that had kind of theoretical models of what we call complex systems, but they couldn't explore it because they didn't have the computational power to study a space of millions and billions of states.
Yes.
And before computers, you were limited on the number of variables that you could consider. And it was only in the 1980s that PCs became available. And then people began studying, say, the relevance of interactions in, let's say, very basic models of complex systems. But now you could consider thousands of variables and run simulations that it's simply not feasible to do with pen and paper. And what happens if you change one value in a computer? You just watch it, and in the paper, it's frustrating.
So, in other words, we have known about complexity and the relevance of these interactions in the natural world. So it's coming from biology and even philosophy.
Yes.
But we basically didn't had enough power of in this first case is brain power, and then we moved that into computer power to really try and understand the meaning of these interactions and their outcomes.
Yes, Heinz Pagels in the late 80s wrote that computers are the telescopes of complexity.
I know.
Making the analogy that before telescopes with our plain sight, we are limited on how much we could see, say in our solar system just until Saturn. And it was less than 100 years ago that telescopes were powerful enough so that we could observe different galaxies than our own. In the 1921, we couldn't see beyond the Milky Way.
That's impressive.
The telescopes, and similar with microscopes. Before microscopes, doctors had this idea that diseases were produced by humors. And what's a humor? Well, that thing that makes you ill.
Yes.
Of course, to deal with disease without knowing which agent is causing it is, let's say, very limited.
It's walking in the dark.
Yeah, and it was only after we had the proper tools to identify the pathogens that, let's say, took lots of time, but then we managed to understand and study and treat infectious diseases.
Perfect. Okay, well then let's go back to the idea of how systems change, or how change is perceived within systems. What are normal causes of change?
Yes, well, change in general, it can trace us back to one of the first debates in Western philosophy between Heraclit and Parmenides. So Heraclit is famous for advocating change, and he has many phrases like you never bath yourself in the same river twice, because there is a constant flow. And on the other hand, Parmenides was like very static. Things are, and there's nothing that can change. And in Buddhist philosophy, it's much more closer to Heraclit, in the sense that there's this idea of impermanence. So everything is impermanent, in the sense that even mountains will change eventually, rocks will change, our planet will change. So there's no point in kind of having an attachment to things. And not only that, but if they change, they're not real. So a condition for reality is that it doesn't change. So the conclusion is that, therefore, all the things around us that we kind of strive for, like fame and money and prestige, a couple, and so on, those will they're impermanent. So they bring suffering first because we don't have them, and once we have them, we will lose them. So the main idea of Buddhism is to try to strive to focus on those things which are permanent, and the things which are permanent are not the things that we observe, but the potential of things themselves. So let's say the mind's nature, as it's called. So one way of interpreting, and let's say not getting all new wavy about it, it's simply to say that the capacity of knowing, that doesn't change. Or let's say the potential of knowing. And if we can focus on that, then we don't have anything to lose, because it has always been there and it will always be there.
Yes, the idea, the capacity of knowing, you mean in terms of what we are capable of discovering, and the knowledge we can get a bit theoretical. This is the idea that never ends.
No, it's much more general because it's beyond humans. It's just you could see it as the potential of information of having meaning. And I mean, yes, that it's almost a tautology.
It's a completely a different level that I was expecting, for sure. But how that relates into a more, if you allow me, a bit pragmatic sense of understanding complex systems, you know, trying to imagine in a very specific example, like, you know, a group of a society, or maybe in an ecosystem, or things like that. No, is the idea that changes come through the collective, or there are things that individuals or individual entities also can do that affect change. And then we can maybe, I don't know, in my mind, I think it connects to the idea of loops, the positive and negative loops. But you are the expert, so what do you think about that?
Well, it's a bit of both. You can have changes that are originated at a lower scale or a higher scale, and in a sense, these scales are also artificial, in the sense that they have to be described by an observer. But I think that the important thing is that, let's say, trying to merge complexity and change. Well, in complex systems, you have interactions. So these interactions, sooner or later, will lead to change. And this, let's say, the technical term for this is non-stationarity. So it means that let's say, in traditional science and engineering, you pose a problem, and that's it. The problem doesn't change. Therefore, if you find a solution to that problem, you're done.
Yes.
However, if you are dealing with an open system that has interactions with the outside, or complex systems that has interactions between the components, it might be that some of those interactions will change the problem, and therefore you need a new solution.
Is not here where maybe we can introduce the idea of emergency, because it's in those interactions that the emergency is produced, no? And could that be how things may move from their previous situation?
There have been huge debates around emergence since the 19th century, and perhaps earlier, because it can be the concept of emergence can be traced back to Aristotle, when he wrote that the whole is more than the sum of its parts.
Yes,
the idea has been around for millennia, but only in the 19th century, in philosophy, people started speaking about it, and only with computers, let's say, that there was a resurgence of philosophical discussions on emergence, but still it's nothing settled, and there are different opinions about it. So to speak about my own opinion, my definition of emergence is when you have information at one scale that is not present at another scale. We usually see this as upward emergence. So for example, there's highway traffic, and the traffic jam is not a property of the individual cars, but you can say that it emerges out of the local interactions. it's not information that is in the elements, but it's a product of the interactions, and therefore it's at a different scale. However, you can also speak about downwards emergence, meaning that, an example is in society that individuals create social norms, and then these social norms regulate the behavior of individuals. So in this sense, it's not enough to describe the social system at individual scale, but you also need the description at the social scale to realize how the social norms, which would be properties of the collective, how they influence the individual behaviors.
Okay, that then, if we can continue with the idea of scale, you mentioned that scale is not defined by the system itself, but is an observer that has to define. Could you elaborate a little bit that more? How scales work in complexity?
Well, there are kind of natural scales at which we can observe systems like atoms, molecules, cells, organisms, societies, biospheres, planets, galaxies, and so on. Mm-hmm. And there have been many people kind of wondering how these scales relate to each other, or which is the real scale. And in reductionism, it's assumed that the lowest scale is the real one, and all the others emerge from that one. Yeah. And actually, they're not real. It's just epiphenomena. So there's no free will, because if we had all the information about your elementary particles, and assuming that there's a finite number of elementary particles, then if you describe yourself at that scale, then you can predict everything that happens at the higher scales. However, when I speak with biologists or sociologists, they have no problem in speaking about downward causation, which would be the description at a higher scale that has that causes behavior of a lower scale. And one example I give of downward causation is money. Mm-hmm. So money is not material, in the sense that you cannot distinguish the value of money by its material constituents. So it could be a gold bar, but I mean, you can have information about the atoms of gold. That won't tell you how much is the price of gold in the stock exchange, or a coin, or bills, or bits that are in your bank account. I mean, the value of money, it's in the social interactions that we agree upon, and we say, okay, these dollars are valuable this amount, and pesos are valuable in this amount, and we agree on the exchange rate, and so on. But it's arbitrary.
Yes.
And actually, the economies in the recent decades that are based on information make this arbitrariness even more evident, because, let's say, after the agricultural and the industrial revolution, we were able to control matter and energy, but the value of products had more or less certain correlation with the amount of effort or work required to produce that element.
But not anymore.
No, when your product is information,
yes,
there's no correlation between the effort or the work required to produce that information and its value. So you can create economic value out of thin air. But then the key is that this value that you can represent in terms of information can have direct causal effect in matter and energy. So you cannot predict, for example, that the atoms that make computer you're using will be extracted from a mountain or from a mine without money. So if you had your full description of the mountain at the atoms, elementary particle level, you wouldn't be able to predict that some humans will come and extract it and transform it and make computers out of it.
Yeah.
And it's not that we are violating the laws of physics. It's just that there's downward causation from the social scale to the material scale, to the atomic scale. And that transforms the matter and energy. And I guess that we're not at a point where we can speak about what's the right scale of description, just like people don't speak anymore about what's truth and what's false in sociology, for example. But being pragmatic and also following the later work of Wittgenstein, we can just speak about what's useful in order to achieve certain goal. This goal can be to communicate or to understand the phenomenon or to predict. And depending on this goal, different descriptions might be more appropriate. And of course, the scale is tied to a description and a goal for that description. Mm-hmm. So we cannot speak that there will be the best scale or the real scale of a phenomenon, but depending on what we're interested in, then we might consider one or more scales of description, precisely if we are interested in understanding how different scales relate to each other.
Yeah, exactly. Yeah, no, I was reflecting while you were talking. When I teach some of these things to my students, I normally tell them the idea of scales, is depending on the specific context that you're working with, and what is the problem you're dealing with, and what is the objective. And sometimes the idea of scaling, going up on a scale or down even to a scale. And I don't know if this will make sense, but you can tell me if I've been mistaken. I'm trying to explain this with an analogy. Say, okay, so imagine that you can shrink yourself down to the level of ants, and you will be seeing ants just moving around in a seemingly chaotic, random way. But as soon as you scale up and you look at from a different perspective, then you can start looking at patterns, and then you can start making some sense of what is going on. Could that analogy be correct? That
yes, if you observe at the ant level, then it's difficult to describe what's going on at the colony level. And also, let's say a similar analogy is whether our cells, or let's say if we would do a similar thing at the level of our cells, what would be something like a consciousness of our cells, and would they realize that they are part of a body? And a similar thing can be said about at the social scale, whether a society or a species or our planet is conscious in a way. I mean, because if our cells are not aware that we are conscious, maybe the planet is conscious or the society is conscious, but we are not aware about it. Okay. And if we were, well, if it was the case, how could we detect it? And I mean,
yeah,
that's an open question, of course.
That sounds like a very interesting rabbit hole to go into, but probably not today. Yeah. I'll hopefully be speaking to a philosopher, and I have an appointment also with a psychologist. So the idea of this consciousness. I mean, I'm going to talk with a cognitive scientist. So the idea of consciousness is certainly quite interesting and polemic at the same point. But anyway, going a little bit forward, talking about behaviors in these systems. What I have learned, what I have read is there are different types of behaviors, and the idea of these behaviors is that some of them can be periodical, constant, but never changing, and some of them are ranging between periodical and chaotical, that you can sometimes make sense, but suddenly things change, and then the chaos. Yes. Could you elaborate a little bit on these type of behaviors? And what I'm particularly interested in knowing is the idea of stability in a system, and how is reached, if it's reached, and if it's broken as well, or could somehow be modified.
Yes, well, the study of different models of complex systems has given on several insights about precisely these different dynamics or behaviors, as you're calling them, in the sense that if you have, let's say, at one extreme, there's no change, meaning there's stability, and then you increase the number of interactions, suddenly there is a bit more of change, and a bit more, and a bit more, and a bit more. And when you have way too many interactions, then you have chaotic behavior or chaotic dynamics. Chaotic dynamics are characterized by sensitivity to initial conditions, meaning that small changes lead to great changes. And in the order dynamics, the opposite occurs. Small changes basically dissipate. They don't have an effect. So you have very robust dynamics. The states of systems are self-preserving. However, usually there's a phase transition between these two dynamical regimes, order and chaotic, and some people call this near the phase transition critical, or also some people call it complex dynamics. And this, you can see it as a balance between the advantages of both extremes of order and chaotic dynamics. So in order dynamics, you have robustness, that it's desirable because you want some things to be preserved. However, if you have too much rigidness, then you cannot adapt. And however, if you have too much adaptability, then you will lose the useful things that you already had, and systems will actually lose their identity. If there's too much change, then you cannot identify what a system is because, let's say, well, changing constantly. So as it turns out, there's this balance between order and chaos that was already noticed in the late 80s. Well, no, even before. Actually, this year is the 50th anniversary of Jacques Monod's essay on chance and necessity, and he precisely speaks about this in biology. Chance being chaos and necessity being order. And many people have elaborated that idea in different ways.
Okay, super interesting. Just moving a little bit ahead, I guess we can, time is flying crazy fast. If we can move to the idea of long-term thinking. And I know it's a very relative concept, the idea of long, whatever long means, but how is long-term concerning systems and complexities is something that is dealt with long-term?
Well, the thing is that many of our systems have increased their complexity, meaning their interactions, meaning that their dynamics become more chaotic, meaning that change is faster, meaning that predictability is more and more limited. So this doesn't mean that we cannot do long-term thinking or long-term planning. It means that it has to be adaptable, because basically we know that the things will change. It's not that we don't know what will happen. It means that we know that things will change, and the rate at which the change occurs is increasing as our world becomes more global. And I mean, we've seen it in recent years, how things change. And some people will say that it's almost useless to plan. I disagree. I think what we should do is to change the way we plan. And we should plan in order to have adaptive systems inbuilt, with an adaptivity inbuilt in them.
It's what you were just saying just prompt some ideas. The idea of globalization, and for example, what we're living now with starting the pandemic, and then all the change of other situations like supply chains and well then social displacements and things that are all somehow connected. My thinking is that we have somehow hyper connected the world.
Yes.
We have increased the complexity because we have increased the connectivity between different areas, different not only physical spaces and societies, but also industry and a bunch of different things. So I don't know if there is a way of, through complexity, understanding when you have gone too far away when these type of things. I know. Yes, I'm looking for a kind of a recipe, but I think there must be a clear understanding of when things are starting to, I don't know if the word is correct, but collapse or just going into a state where is the predictability of whatever is it that is going to change is just going out of the window.
Yes. First of all, let me go back a bit in the sense that most of the history of our culture can be described in terms of us humans trying to control of our environment in order to make it more predictable. Agriculture makes it more predictable to have food. Let's say industrial revolution makes it more predictable to do many things. Increase of life expectancy makes it more predictable. Let's say many things are becoming more predictable, or let's say were becoming more predictable until recently. And actually, it's this increase in predictability that allows for economic development. In countries that have too much change, meaning that there's a revolution every now and then, they cannot have accumulation of wealth. And also there aren't incentives for accumulating wealth, because you don't know what that, let's say, who will be the next despot to to take over. Many of our institutions were made precisely to generate stability and predictability. And I mean, many people use the word security.
Yeah, but at the same time, it made it more fragile, no?
Well, that's a result of the increased connectivity or complexity, which was possible only because of the predictability that we achieved. But let's say the same, let's say, progress or evolutionary curve is allowing us to create systems that are more interdependent, and that limits the predictability. And I think that, of course, the solution is not like, okay, let's go back a bit and we'll stay in the industrial state and no more inventions will be made. No. I mean, of course, it's not possible nor desirable. I think that the way forward is to understand complexity and to harness it, not to neglect it. And one way of doing it is with self-organization.
Yeah, I don't know if well, because I had some crazy ideas that may connect here. I don't know if self-organization and scale could be connected, because I just read just before talking to you, I was reading a post that Joe Norman, you know him, is also an expert in complexity. He wrote some sort of article essay in his blog about the inevitable of localism, the coming back of localism, and also connects a lot with what I've been reading in anthropology, for example, and things that relate to social justice and even decolonization. The whole idea that, just to put an example, in order to be more resilient, we need to embrace diversity. That doesn't mean that we need to go back and live in caves and we don't need to export and import things anymore and travel anymore, but it's the idea that complexity needs to be understood, I think, and these interactions, I don't have a word for it. So we need to do something with these interactions, and the idea of allowing certain degree of globalization or globality, if you allow me the term, I don't know if it exists, within the local. But I don't know if what you were trying to connect with self-organization may have to do with what I was just saying.
Yes, because it's, let's say, first, self-organization, it's a phenomenon that is prevalent also in complex systems. Typical examples: flocks of birds, schools of fishes, insect swarms, crowds, and so on. Let's say if we get all philosophical about defining what's a self-organizing systems, we will enter another rabbit hole. But let's say you can describe a self-organizing system as one in which the components interact to produce a global pattern or behavior. And then you could say that for almost any system, but then it's okay, when is it useful to describe systems in such a way? And it's precisely when you have this non-stationarity, when you have enough complexity so that the rules of the system will change, then your predictability is limited. But then, since you're not trying to solve a problem that will be obsolete because of interactions, then an alternative is to design the interactions of the components of a system so that they will be constantly seeking solutions. So as the problem changes, they will adapt.
Yes.
And we've applied self-organization to solve all sorts of non-stationary problems, and they can, in some cases, be even better than the theoretical.
Okay, yeah, no, it's brilliant. This reminds me of one of the projects that I did with one of my students. The idea of constantly being aware of the need for adaptation, and the constant tracking of these interactions to adapt when it's appropriate, when it's still good time, a proper time, whatever that may mean. Yeah, we were talking about predictability. Why are we so obsessed with predicting everything from
Because we're control freaks. No, because we have the misguided idea that we can, and it's difficult to kind of let things flow and don't have control over things. It's kind of natural reaction to want the things we like and not want the things we don't like. Therefore, we try to do everything so that the things we like we get, and the things we don't like we don't get.
And you think, knowing your interest in Buddhism, you think this is an overall thing in the world with all the different cultures or is more kind of a Western type of thing because of a tradition of reductionism in science? I will imagine that especially Buddhism has a different view on these things.
Yes, so Buddhism sees this as disturbing emotions, basically attachment. So we are attached to what we want, and we have aversion against the things we don't want. So when we don't get what we want, or we get what we don't want, we get anger.
Yeah.
And that's another disturbing emotion. And well, but that does not apply only to humans. It applies to all beings, basically, because we want to preserve ourselves, and with that we could jump into boundaries.
Oh, well, yeah, exactly. That's time is flying. I'm just worried that I'm taking too much of your time. The next topic is precisely limits that we can talk about.
Yes.
About boundaries. No, is that there an inherent limit to our ability to study or intervene complex systems? Or we can even start before. You were mentioning these scales and the systems within systems, and there is no real boundaries. So if we talk about limits or constraints, maybe what they refer.
Yes. So the last book of John Holland, who could be considered one of the fathers of complex adaptive systems, is titled Signals and Boundaries. So that book, I mean, it's not a thick book, but it's very interesting. And he speaks about signals, which could be seen as interactions or information exchange, and boundaries. When we speak about limits, we in many cases think about physical limits. So a wall would be a limit, a membrane in cells and so on that separate a system or an entity from its environment.
Mm-hmm.
Perhaps our skin could be also seen as a limit or boundary. And in a world that is dominated by matter and energy, then these limits are more or less well defined.
Mm-hmm.
But as we have moved in the information age to study more phenomena that are based on information, these limits become more and more arbitrary. So there's a question, what's the limit of our mind? In cognitive science.
Yes.
I mean, this comes from the 1990s, or, well, of course, since antiquity, but let's say in the 1990s, David Chalmers and Andy Clark published a paper where they present their extended mind theory. And the basic idea is that it's difficult to say that the boundaries of our mind, it's our body or our skin, our flesh, because our mind is distributed, and we have information processing in our brain, but that information processing can also take place outside our bodies. Then why shouldn't we say that that information processing is not part of our mind? And they also speak about cognitive scaffolding, and well, there's a huge debate because the people against this, they say, well, that information processing outside your body, it's kind of a tool, but it's not part of your mind. Just like a walking stick is a tool for walking, but it's not another leg. Mm-hmm. So of course, where do you draw the boundary? No, but actually, a few years ago, I went skiing for the first time, and it was very interesting when I got the feeling that the skis were part of me. Or, let's say when I stopped feeling the separation between the skis and my body. And it's not that the skis are part of my body, but let's say when you are skiing, the coordination is as if they are part of your own body.
That, yeah, no, that gives for a lot of ideas. No, I just connect with the work of Giselle Mihagi,
Yes.
and the idea of how your senses and your cognition also goes outside your body in different ways. Anyway, we could stay here talking for a few hours for sure.
But just let me complete about the limits.
Yes.
And relating it to the multiple scales, because then it becomes arbitrary. And actually, this was a problem already in cybernetics and systems theory, because let's say it becomes arbitrary where you draw the boundary of a system, how you identify the components of a system, how do you describe the aspects of a system that you're interested in. And of course, if you change the boundary of a system, then many things might change. And also, of course, if you observe the system at different scales, then different boundaries will appear or will become more or less relevant.
Yes.
So it's not that one is better than other, it's just that some are more useful to understand phenomena for a specific purpose than others. But this idea that the limits in many cases are arbitrary, or another way of saying it, they are socially constructed, is still difficult to accept.
Yeah, well, yeah, I guess it depends on many things. You will have to be much more precise in terms of what you're trying to describe in order to be specific, no? But we've been mostly talking about physical things, but what about non-physical limits? I'm thinking about rules. Systems have also rules in their behaviors, and that somehow also limits what certain actors or certain functions can be.
Yes, actually, that's an essential aspect of complex systems and their evolution. Stuart Kaufman, in one of his books, he speaks about systems that build their own constraints. And actually, that's more or less what life is about. Because, of course, Maturana and Varela, when they speak about autopoiesis, meaning self-producing systems, it's a system that constructs its own boundary and then kind of maintains its own identity, separating itself from its environment, even when there are interactions with its environment, but there are much more interactions within the systems than with the outside. And also it maintains an identity, so it also kind of limits the change that comes from the outside. So in evolution, those successful systems or viable systems are those that actually are able to limit the variety incoming from the environment, or basically the change that occurs around them, and are stable enough to maintain themselves. But also one can speak about information that produces itself or creates constraints so that it propagates more effectively than other types of information. And this can apply at all scales.
Yeah, but does that reduces resiliency?
No, actually, it's a condition for resiliency, that you are able to maintain your identity, and boundaries is a great way of doing it.
Yeah, I get. Yeah, yes. I guess what I'm imagining is if you are dependent from the outside. So you're talking about closed system. Because if it's an open system, I mean, if this, let's say, entity or organism requires some exchange from the outside, and then you're limiting that exchange. I don't know. I'm getting confused.
I think there are only closed systems in textbooks.
Okay, good point. Good point.
I mean, you cannot isolate anything. First of all, because we can observe it, they're not isolated. If they were isolated, we would not be able to observe it.
Yeah, good point. Yeah, but that was precisely my thinking. No, if that reduces, if that kind of isolation, if you want, reduces resiliency. Because for me, I don't know if the idea of resiliency should be built. I'm just reflecting while I'm speaking. So forgive me if I say nonsense. Is resiliency dependent exclusively from within whatever system needs to be resilient is not obviously not dependent from the outside, otherwise it won't be resilient.
I think it's both, because if the environment is very static, almost any system will be resilient.
Yeah.
On the other hand, if the system is chaotic, in order to withstand so much change, basically the only, I mean, it might be too much change so that the system can adapt. So the only solution is just to try to be as stationary as possible.
Yeah. Okay, good. Yeah, no, there are several things that I would like to explore that, but we need to start closing here. So before I go to the final questions, just one more within the limits idea. I have this question. I don't know even if it makes sense, but I'm going to shoot it anyway. So differences in efficiency limits in centralized and distributed systems. What could you elaborate with that?
Well, you can have centralized control or distributed control or self-organizing control. And you cannot say that one of these is better than other independently of a context. So it's precisely what are you trying to control?
Okay.
If the system has very low variety, meaning that there's not much change, then centralized control is perfect. And if the problem is stationary, you solve a problem, you find a solution, and you're done. However, if you have a non-stationary problem, then you know that you won't be able to predict everything. Therefore, you're better off with self-organizing control. And each of these would require different limits, different boundaries at the system level and at the component level.
Interesting. That makes it clearer for me, for sure. Thank you very much. So I normally end the interviews with 3 questions that are really philosophical, really open. No right or wrong answer, is whatever comes to mind. So here goes the first one. Is the longest living species in the planet are cyanobacteria that have existed for around 2.5 billion years. And from comparison, and the oldest standing human-made structure is just a few thousand years. So how do you see human development feasible from this point of view? Is it even feasible to think that we humans can even attempt to last for that long as a species? What we should be expecting the evolution will bring us?
Yes, that's a very interesting question. Let me, before I try to formulate an answer, there's this hypothesis. I forget the precise name. It's something like sauropod or something. Well, it basically the idea: what if dinosaurs had a civilization as advanced as ours? How would we know? Because let's say it was tens of millions of years ago. So even if they had, I don't know, plastics, they would be degraded. How could we find traces of that civilization? And this also kind of posed the question, well, if, let's say, some aliens arrive on Earth in 100 million years and our species isn't here, what would be the remains of our civilization? And you can apply the same question to other planets and so on. So for example, what about Mars? Do it have an advanced civilization? Yes or no? What remnants would there be? What evidence that something like a civilization occurred? Because it seems that it's the first time on Earth's history that a species has managed to transform so much the planet. So the question is like, well, maybe it happened and there's no evidence left because it's so ephemeral, in the sense that we might wonder whether our society, a global society, will degrade in a few centuries into hunter-gatherers, as it has happened throughout history. So, for example, the natives in Tasmania, they even forgot how to make fire when the European colonists arrived. And what Jared Diamond has written about this.
Yes.
And of course, it's an open question. However, if we don't focus on, let's say, our own species, but at a broader or longer evolutionary tendency towards higher complexity, we could say that even if we screw up everything and kind of destroy ourselves with nuclear weapons, sooner or later there will be another species which will reach a similar point, and they might have a different path. If you observe the evolutionary tendencies, you kind of have increased complexity at one scale, and then there's a transition at a higher scale. And this transition is characterized by reduction of the freedom of the lower scale, because there are mechanisms that control the behavior of the lower scale, but an increased survivability of the lower scale. So for example, our cells, they are less free, but they are much better off as part of multicellular organisms than if they would be unicellular organisms. So not speaking about our civilization, but about civilizations in general, all potential civilizations of all species that might evolve. I think sooner or later, hopefully within, and of course, this is not something that we will see within our lifetimes, but maybe in a few millennia, if our species don't change too much or are destroyed, I don't think our species will be destroyed. I think more it will be transformed. And there's a very strong evolutionary pressure so that the society and at our technological development level, it has to be a global society, will implement the mechanisms or restrict our individual behaviors, will put the boundaries to our behaviors so that we can coordinate for the benefits of the higher scale. And this would limit our freedoms, but it will increase our survivability. So it's, again, kind of increasing the predictability or the long-termness of our dynamics at the cost of restricting our possible behaviors. But at the same time, it will create new scales of complexity where new things will be able to evolve.
Great answer. It connects to some of the things that I've been listening and reading, but I won't go there. We don't have much more time, so I'll move to the next question. So the importance of failure in discovery and human progress. What do you think about the importance of failure? Because we are very good at punishing failure, and almost every scientist, surely every scientist that I have talked to, failure is an essential part. But if you just give us your take on this, what do you think about failure?
Yes, well, Alan Turing, who we could say he's father of computers and artificial intelligence, he wrote in a letter something like, if we want computers not to fail, then they won't be able to be intelligent. So basically, he was characterizing intelligence or failure as a part of intelligence, or basically the ability to recover from failure as part of intelligence. And if you want a perfect machine that will not make mistakes, it won't be able to be intelligent because it won't be able to learn. So I will apply that argument towards robots, to ourselves, and say that if we don't fail, we won't be able to learn from our mistakes. And let's say failure is inherent, and also since our predictability is limited by complexity, we are bound to fail because problems change constantly. So even if we solve a problem, the problem will change and we will fail.
So I'm imagining what the answer may be, but anyway, I'm gonna ask why then you think, at least in some areas of human life, failure is so punished, especially politics and other things.
Yes, I guess it comes from the same kind of primordial attachment towards having what we want, rejecting what we don't want. So we want things to work for us. We want to get what we want. It's redundant, but I would quote Samuel Beckett and just say fail better.
Yeah, no, it makes sense. It makes sense completely. So no, it's great. You're giving me some interesting stuff to talk with the philosopher and the psychologist. So final question here is you somehow already answered this one, but let's give it a try again. So describe for us the future of your choosing. And first you pick your future, how long distance your future may be, 100 years, 1,000, 10,000, or even more if you want, and how it would look like.
Well, let's pick the shortest one because it's the easiest to imagine.
Okay.
So 100 years, I don't think we'll change that much in 100 years, in the sense that we'll still be humans and machines will not have conquered us.
That will be another topic to talk to you about, but not today, I'm sorry. But artificial intelligence for sure.
Well, the short answer is no, they won't take over. Let's say the machines are inherently limited, but yeah, that's another question. Yes, so I think it will be very similar. Let's say my hope is that in the next century we will find solutions to many problems that we are facing, including climate change. However, given the experience of the pandemic and its ongoing history, I'm not very optimistic about it. So most probably we will run into severe tragedies caused by our inability to coordinate at the global level. And I mean, if we can deal with the pandemic, we have no chance with climate emergency. However, this might create new opportunities because it will disrupt severely our political systems and our economic systems. So this will give an opportunity for change, and hopefully the new organizations, the new institutions will be a bit more equitative and democratic than the ones we have now. Yeah, I have no idea to what extent we will manage to achieve this increase in equality. I don't think we will solve all problems. We will still have lots of problems and we will create new problems on the way. But I think that's our failure. Well, hopefully we will learn from our failures with the pandemic and with climate change and so on. That will allow us to be a bit better prepared to face new challenges and to understand complex systems in a better way.
Excellent. Thank you so much, Dr. Gershenson. It's been fantastic. It's been a truly amazing experience. I appreciate very much all your input. It's been great. Tons of things to think about now. Thank you again for being here.
Pleasure.
I hope you have enjoyed that conversation. I found it quite interesting and very challenging, to be honest. At some points, I was trying to follow up some of the ideas, and it took me a little bit of time sometimes to really process the information, and certainly gives for a lot of thinking and more exploration about these topics. It's truly fascinating. I had the honor to hear Dr. Gershenson like 15 years ago, and he was the source of inspiration to get closer to the ideas of complexity and systems thinking, systems theory. As always, just a couple of thoughts as final reflection. It's incredibly interesting how fast connects complexity with philosophy. It's something that I was aware of, but in this conversation, it really struck me how easily you can move from talking about very technical things and move really fast into high-level philosophical topics. The other point I think is very important to highlight is the trend of increased complexity that Dr. Gershenson was talking about, that the world we live in now is very connected and therefore more complex. And with more connectivity, the more interactions, and change becomes more common and happens faster, and therefore is also less predictable. Think how this affects culture, politics, and business. It will make more sense what we see in the TV news at night. And reflecting on this, I see a relation to the answer to my question about control and efficiency. Dr. Gershenson responded that when the system has no variety, so it does not change that much, centralized control can work perfectly fine. But when it changes a lot, when there is no predictability, is non-stationary, then you're better off decentralizing. So the idea of this trend of increased complexity and decentralization, at least to me, makes me think that what I have been reading from other fields and also from interviews that I am currently editing and will soon come to you with experts in economics and agriculture, for example, that going back to the local makes complete sense. This idea of going back to the local will be explored in more episodes to come. But right now, I will just say that somehow we will need to find a way to allow this decentralization with the goal of increasing resiliency in our communities and regions, and at the same time maintaining the interaction between regions and different communities and overall unity in a global perspective. To my view, this even connects to what Dr. Gershenson said about our reaction to the pandemic, that he is not very optimistic, that our inability to coordinate at a global level caused severe disruptions. But then when talking about the evolutionary tendency to a higher complexity and how, for example, our cells are better off than unicellular organisms, talking about higher and lower scale, our cells give up some freedom in order to belong to a higher scale organism. This evidently was not conscious decision by our cells, it's an evolutionary effect, but serves, I think, as a guidance for a better understanding of our current situation, facing the enormous challenge that climate change is, as we are bounded by the same rules of complexity and evolution. Nowadays, freedom is a very loaded word. It's a very complex word. It is being used in extremes, and it is hard to comprehend what individual freedom actually is, especially when being part of a society, a higher scale organism. I think there is no absolute freedom. If you want to live in a society, the freedom of an individual ends when it collides with the rights of another individual. So it is crucial to understand that in order to increase our survivability as a collective, we need to constrain some individual freedoms to a certain degree. What degree and what point? Well, we need to talk about it for sure, but it can be tricky because someone can always try to abuse from others. But just to be more precise, when I talk about individual freedoms, what I have in mind is what we need to do, each one of us, in order to fight climate change, especially citizens of the global north and our excessive consumption and myopic obsession with growth, topics that also will be further discussed with another experts in this podcast. Of course, we have the right and the need to consume things, but when is too much? When it starts to be unfair? How can we even know when it's unfair? And what happens when we realize the negative effects of our excessive consumption is causing to hundreds of millions of people all around the world that mostly have no contributed to climate change, or the severe negative effects that will cause to future generations? Let's not forget that cooperation has been one of the most important human traits that allowed us to evolve into the species we are right now. And well, with this, I think is enough. I appreciate very much that you join us again in these conversations. If you like it, please comment and subscribe. There are more conversations, more interviews coming, so don't forget to come back. Thank you very much and see you next time. Future Exploration is produced and written by me, Victor Martinez. Music is composed by Rafael Crux, Udayana Lugo, and Mauro and Daniel Martinez. Future Exploration is licensed under the Creative Commons with attribution and non-commercial use.